Not all calories are created equal, and emerging research highlights how the type of calories we consume, particularly from foods like pistachios, can have far-reaching effects on the gut microbiome and metabolic health, even when total energy intake remains the same. Traditional nutrition thinking often reduces diet to a simple math problem: calories in versus calories out. However, this perspective misses the intricate interplay between nutrients, microbial ecology, and host metabolism. Two diets with identical caloric content can produce dramatically different metabolic outcomes depending on their macronutrient composition, fiber content, and polyphenol profile, and pistachios offer a compelling example of how nutrient-dense, fiber, and fat-rich foods can rewire the microbiome for systemic benefits. When isocaloric diets are compared, one high in refined carbohydrates and low in fiber, and the other incorporating pistachios to provide equivalent calories from a combination of fat, protein, and fiber, distinct differences in microbial ecology emerge. Pistachios provide fermentable fibers, resistant starches, and polyphenol that reach the colon largely intact, feeding beneficial bacteria such as Faecalibacterium prosnitziae, Roseburia, and Bifidobacterium species. These microbes produce short-chain fatty acids, SCFAs, like butyrate, propionate, and acetate, which play key roles in gut barrier integrity, systemic inflammation regulation, and glucose metabolism. By contrast, diets that provide the same caloric content primarily from refined carbohydrates may foster microbial communities less capable of producing SCFAs, while favoring species associated with inflammation, increased gut permeability, and metabolic stress. This illustrates that the metabolic impact of a food cannot be judged solely by its caloric contribution. The fiber and polyphenol content of pistachios also helps modulate glycemic responses. Even when carbohydrate calories are matched, pistachios slow gastric emptying and reduce postprandial glucose excursions through both direct macronutrient effects and microbial fermentation products. SCFAs produced from pistachio fibers can signal the liver to regulate glucose output more effectively, enhance peripheral insulin sensitivity, and promote satiety hormones such as GLP-1 and PYY. This combination leads to better glycemic control and reduced insulin demand despite the same caloric intake. In contrast, carbohydrate-heavy snacks often trigger rapid glucose and insulin spikes, which over time contribute to insulin resistance, fat accumulation, and low-grade systemic inflammation, showing that caloric equivalence does not equate to metabolic equivalence. Furthermore, pistachios encourage microbial diversity, a key indicator of gut resilience. A diverse microbiome can better metabolize a range of dietary substrates, buffer inflammatory signaling, and maintain barrier function. Studies comparing isocaloric interventions suggest that substituting refined carbohydrate calories with pistachio-derived calories increases the abundance of SCFA-producing microbes and enhances microbial metabolic activity, creating a gut environment that supports improved lipid metabolism, lower systemic inflammation, and enhanced energy utilization. Over time, these microbiome-mediated changes can contribute to improved fasting glucose, reduced postprandial spikes, and better overall metabolic health, highlighting the unique functional properties of pistachios. The healthy fats in pistachios, primarily monounsaturated and polyunsaturated fatty acids, further amplify their metabolic impact. These fats modulate lipid profiles, reduce inflammation, and interact with gut microbes to influence bile acid metabolism, which in turn can affect microbial composition and SCFA production. Protein from pistachios also contributes to satiety and glucose stabilization, ensuring that the same caloric intake delivers a slower, more sustained energy release. Together with fermentable fibers, these nutrients create a nutrient matrix that interacts synergistically with the microbiome, producing systemic effects that simple carbohydrate calories cannot replicate. This insight carries practical implications for dietary planning. For individuals aiming to improve glucose control, metabolic flexibility, or gut health, focusing on nutrient quality rather than caloric counting can yield more meaningful results. Replacing carbohydrate calories with pistachios or other fiber and polyphenol-rich foods allows the microbiome to thrive, encourages SCFA production, supports gut barrier integrity, and moderates systemic inflammation. This approach underscores the importance of food as functional medicine, where the metabolic fate of calories is shaped by their interaction with microbes rather than simply their energy content. In essence, pistachios demonstrate that calories are not created equal. Even when matched for carbohydrate calories, their unique combination of fiber, polyphenol, protein, and healthy fats rewires the microbiome to promote SCFA production, microbial diversity, and systemic metabolic benefits. They highlight a key principle of modern nutrition science. The quality, composition, and functional properties of calories matter at least as much as quantity. By choosing foods like pistachios, people can achieve equivalent energy intake while simultaneously fostering a microbiome that supports glucose regulation, reduces inflammation, and strengthens overall metabolic resilience, showing that thoughtful food choices have the power to transform metabolism from the inside out.